422.11 applies to counter-mounted cooking units. The combination gas cooktop electric oven is not a counter-mounted cooking unit. It is a cooktop and oven is sold as a single unit, typically in a cabinet or cutout in a countertop. Therefore, 422.11 does not apply to this appliance. Since 422.11 does not apply, the overcurrent protection for the combination gas cooktop electric oven must comply with the requirements of NEC Article 422.16. This article states that the appliance shall be protected against overcurrent in accordance with Article 210. Using Note 4 to Table 220.19 and Exception 1 to 210.193 would allow the 4.8 kW appliance to be protected at 50 amps. These notes and exceptions allow for the use of a higher ampacity branch circuit for an appliance that is expected to draw lower current than its rated load. However, these notes and exceptions do not apply to appliances that have a nameplate rating that specifically states the minimum circuit ampacity. The combination gas cooktop electric oven described in the scenario is not a counter-mounted cooking unit and therefore is not subject to 422.11. The overcurrent protection for this appliance must comply with Article 422.16 of the NEC. While Note 4 to Table 220.19 and Exception 1 to 210.193 could be used to allow the 4.8 kW appliance to be protected at 50 amps, these notes and exceptions do not apply because the appliance has a nameplate rating that specifically states the minimum circuit ampacity. Let's delve deeper into the nuances of electrical codes concerning ovens and cooktops. Firstly, it's critical to differentiate between a counter-mounted cooking unit and a combination gas cooktop electric oven. A counter-mounted cooking unit, as defined by the NEC, typically refers to a cooking element that is integrated directly into the countertop surface. These units often lack a separate oven compartment and are primarily designed for stovetop cooking. On the other hand, a combination gas cooktop electric oven represents a single, integrated appliance featuring both a gas-powered cooktop and an electric oven. This type of appliance is typically installed within a cabinet or a cutout in the countertop, forming a cohesive cooking unit. Now let's focus on NEC Section 422.11. This section specifically addresses the overcurrent protection requirements for counter-mounted cooking units. However, it's essential to recognize that this section does not apply to combination gas cooktop electric ovens because they are not classified as counter-mounted cooking units. Instead, these integrated appliances fall under the general overcurrent protection guidelines outlined in NEC Article 422.16, which mandates compliance with Article 210. Article 210 of the NEC provides comprehensive guidelines for branch circuit wiring, including the overcurrent protection requirements for various types of appliances. It's crucial to ensure that the overcurrent protection device, such as a circuit breaker or fuse, is appropriately sized to protect the appliance and the branch circuit conductors from overloads and short circuits. Now, let's consider the application of Note 4 to Table 220.19 and Exception 1 to 210.193. These provisions within the NEC offer some flexibility in determining the ampacity of branch circuits for certain cooking appliances. Note 4 to Table 220.19 allows for demand factors to be applied to the total load of household cooking appliances when calculating the service or feeder size. This means that you might not need to size the service or feeder conductors based on the full nameplate rating of all the cooking appliances, as it's unlikely that all appliances will be operating at their maximum load simultaneously. Exception 1 to 210.193 provides a similar allowance, permitting the use of a branch circuit with a higher ampacity than the nameplate rating of a cooking appliance under certain conditions. This exception is typically applied when the appliance is equipped with controls that limit the maximum current draw. However, it's crucial to understand that these notes and exceptions are not universally applicable. They are subject to specific limitations and conditions outlined in the NEC. One critical limitation is that these provisions do not apply if the appliance's nameplate specifically states the minimum circuit ampacity required. In such cases, the appliance must be connected to a branch circuit with an ampacity equal to or greater than the value specified in the nameplate. In the scenario of a combination gas cooktop electric oven, if the appliance's nameplate indicates a minimum circuit ampacity, that value must be adhered to, regardless of whether Note 4 to Table 220.19 or Exception 1 to 210.193 might otherwise permit a lower ampacity. To summarize, the overcurrent protection requirements for ovens and cooktops are governed by specific provisions within the NEC. Combination gas cooktop electric ovens are not considered counter-mounted cooking units and are therefore not subject to the requirements of 422.11. Instead, they fall under the General Overcurrent Protection Guidelines of Article 422.16, which mandates compliance with Article 210. While Note 4 to Table 220.19 and Exception 1 to 210.93 may offer some flexibility in sizing branch circuits for cooking appliances, these provisions are not applicable if the appliance's nameplate specifies a minimum circuit ampacity. In such cases, the nameplate rating takes precedence. Now let's delve deeper into the specifics of overcurrent protection for electrical appliances, particularly focusing on scenarios involving ovens and cooktops. Overcurrent protection is a fundamental safety measure designed to prevent electrical fires and equipment damage caused by excessive current flow. This protection is typically provided by circuit breakers or fuses, which are designed to interrupt the circuit when the current exceeds a predetermined level. The selection of the appropriate overcurrent protection device is crucial to ensure both safety and proper equipment operation. The NEC provides detailed guidelines for selecting overcurrent protection devices based on the ampacity of the conductors and the characteristics of the appliances being protected. In the case of ovens and cooktops, the overcurrent protection requirements are primarily governed by Article 422 of the NEC, which specifically addresses appliances. As previously mentioned, Article 422.16 mandates that appliances be protected against overcurrent in accordance with Article 210. This means that the overcurrent protection device must be sized to protect the branch circuit conductors supplying the appliance. The ampacity of the conductors must be sufficient to carry the appliance's load, and the overcurrent protection device must be rated to interrupt the circuit before the conductors overheat and cause a fire. In addition to protecting the conductors, the overcurrent protection device also serves to protect the appliance itself from damage caused by overloads or short circuits. If the appliance experiences a fault that causes excessive current to flow, the overcurrent protection device will trip, interrupting the circuit and preventing further damage to the appliance. It's important to note that the overcurrent protection requirements may vary depending on the type of appliance, its power rating, and its specific characteristics. For example, some appliances may have internal overload protection devices that supplement the branch circuit overcurrent protection. These internal devices are designed to protect specific components within the appliance from overheating or damage. Now let's consider the role of nameplate ratings in determining overcurrent protection requirements. The nameplate of an electrical appliance provides essential information about its electrical characteristics, including its voltage, current, and power consumption. This information is crucial for selecting the appropriate branch circuit conductors and overcurrent protection devices. As previously mentioned, if the appliance's nameplate specifies a minimum circuit ampacity, that value must be adhered to when sizing the branch circuit conductors and overcurrent protection device. This ensures that the appliance receives an adequate supply of current and that the circuit is protected from overloads. In the absence of a specified minimum circuit ampacity on the nameplate, the overcurrent protection device can be sized based on the appliance's rated current or power consumption. The NEC provides guidelines for calculating the appropriate overcurrent protection device size based on these values. It's important to consult the NEC and follow the manufacturer's instructions when selecting overcurrent protection devices for electrical appliances. Incorrectly sized overcurrent protection devices can lead to nuisance tripping, equipment damage, or even electrical fires. Now let's discuss the practical implications of these code requirements in a real-world scenario. Imagine you are installing a new combination gas cooktop electric oven in your kitchen. The first step is to carefully review the appliance's nameplate to determine its electrical requirements. The nameplate will typically indicate the voltage, current, and power consumption of the appliance. It may also specify a minimum circuit ampacity. Based on this information, you can select the appropriate branch circuit conductors and overcurrent protection device. For example, if the appliance requires a 240 volts, 30 amps circuit, you would need to install a 10 American wire gauge copper conductor with a 30 amps circuit breaker. If the nameplate specifies a minimum circuit ampacity of 40 amps, you would need to use a larger conductor, such as 8 American wire gauge copper, and a 40 amps circuit breaker. Once you have selected the appropriate conductors and overcurrent protection device, you can proceed with the installation. It's important to follow all applicable codes and regulations when installing electrical wiring and appliances. If you are not comfortable working with electricity, it's best to hire a qualified electrician to perform the installation. In conclusion, overcurrent protection is a critical safety measure that protects electrical appliances and wiring from damage caused by excessive current flow. The NEC provides detailed guidelines for selecting overcurrent protection devices based on the appliance's electrical characteristics and the ampacity of the conductors. It's important to consult the NEC and follow the manufacturer's instructions when selecting and installing overcurrent protection devices. By following these guidelines, you can ensure the safety and proper operation of your electrical appliances. Now, let's explore the concept of branch circuit ampacity and its relationship to appliance ratings and overcurrent protection. Branch circuit ampacity refers to the maximum amount of current that a branch circuit can safely carry. The ampacity of a branch circuit is determined by the size of the conductors, the type of insulation, and the ambient temperature. The NEC provides tables that specify the ampacity of different types of conductors under various conditions. It's crucial to select conductors with an ampacity that is sufficient to carry the load of the appliances connected to the branch circuit. If the conductors are undersized, they can overheat and cause a fire. In addition to the conductor ampacity, the overcurrent protection device must also be sized appropriately. The overcurrent protection device must be rated to interrupt the circuit before the conductors overheat and cause a fire. The NEC provides guidelines for selecting overcurrent protection devices based on the conductor ampacity and the characteristics of the appliances being protected. As previously mentioned, if the appliance's nameplate specifies a minimum circuit ampacity, that value must be adhered to when sizing the branch circuit conductors and overcurrent protection device. This ensures that the appliance receives an adequate supply of current and that the circuit is protected from overloads. In the absence of specified minimum circuit ampacity on the nameplate, the overcurrent protection device can be sized based on the appliance's rated current or power consumption. The NEC provides guidelines for calculating the appropriate overcurrent protection device size based on these values. It's important to note that the branch circuit ampacity must be sufficient to supply all of the appliances connected to the circuit. If the total load of the appliances exceeds the branch circuit ampacity, the circuit will be overloaded, and the overcurrent protection device will trip. This can be a nuisance, and it can also be a safety hazard if the overcurrent protection device is bypassed or improperly sized. To avoid overloading a branch circuit, it's important to carefully calculate the total load of all the appliances connected to the circuit. This calculation should take into account the rated current or power consumption of each appliance. If the total load exceeds the branch circuit ampacity, you will need to either reduce the number of appliances connected to the circuit or install a new branch circuit with a higher ampacity. In some cases, it may be possible to use load management devices to reduce the peak demand on a branch circuit. Load management devices can automatically shed loads when the circuit is approaching its capacity, preventing overloads. These devices can be particularly useful in situations where there are multiple high-demand appliances connected to the same circuit. For example, a load management device could be used to automatically turn off a water heater when an air conditioner is running, reducing the peak demand on the circuit. In conclusion, branch circuit ampacity is a critical factor in ensuring the safety and proper operation of electrical systems. It's important to select conductors and overcurrent protection devices that are appropriately sized to carry the load of the appliances connected to the circuit. Overloading a branch circuit can be a safety hazard and should be avoided. By carefully calculating the total load of all the appliances connected to a circuit and using load management devices when necessary, you can ensure that your electrical system is safe and reliable.